So, all right, let's see. Yeah, and I guess I'm sharing my screen correctly. Let's see. Okay, there we go. So yeah, hi everyone. First of all, thanks for having me here. Name is Juho Jantunen. I'm a senior solutions architect in the AWS Game Tech team. So and I'm going to do a talk, a bit more technical, but just a little bit on deploying a game globally. Just a bit on my background. So been making games since I was around 10 years old and got the first copy of the Games Factory. And I've been in the industry since roughly 2009, since I graduated, and been at AWS now for a few years, helping our games customers across Europe to architect their game backends on AWS. All right, so yeah, I'm going to focus more on sort of deploying your game and the sort of infrastructure side and some of the services we have around that. So, but let's start with why do you need a global infrastructure for your game? So there's a few sort of very common reasons for this. First one is session-based games. So in case you're building like a first-person shooter or any real-time session-based game, you definitely need low latency for your players, regardless of their location. And this essentially means that you need to actually be physically present around the world, just because of the limitations of the speed of light to get that latency for your players. So being close to the players, hosting your games are as close to the players. Another one is game backends. This is typically not that latency sensitive. So this would be anything from your sort of player data management to your chat functionality and stuff like that, or matchmaking, for example. But still, you might have low latency requirements for some parts of it, such as chat, for example. Or if you're building like a single player game and you're sort of validating all the player actions on the server side, you might have low latency requirements. And also for this, you might want to deploy to multiple locations, maybe not as many as for session-based games, but you might have like a backend per continent or use some sort of acceleration to your backend, and we'll discuss the options later on. And then we have content delivery. So it's pretty common nowadays on any platform, essentially, to sort of provide updates to your game as a download. So instead of sort of taking the next or uploading a new build to the App Store that you're using, you instead just download it directly to the client and using a content delivery network and sort of caching the content close to the players to the edge is a very common requirement. And then wanted to separately mention China. Of course, like as we will probably hear in the other talks, there's a lot of things you need to consider in addition to just the infrastructure, but definitely, like if you're planning to release your game in China, you definitely want to have your infrastructure there as well, as the connectivity from there to the rest of the world is not very reliable, and you always also have typically sort of regulatory requirements to have that data there, and that also applies to some other regions. You might have the same requirements in Europe, for example. All right, so briefly on why build in the cloud. So if you're not super familiar with the cloud, so one of the key things is reduce downtime and save on costs. So being able to actually deploy close to your players, being able to use the highly available infrastructure of the cloud reduces your downtime, and you can save on costs by scaling based on your needs. So typically, if you run a multiplayer real-time game or any game that has sort of metrics on how it's used, you know that there's a sort of a curve of usage over the day, and in the cloud you can actually scale based on that usage and only pay for the resources that you need. And same goes with of course the lifetime of your game, so depending on how the capacity needs change. Increasing productivity and efficiency, so making use of managed services instead of like worrying about infrastructure, focusing on deploying new features and using things like infrastructure as code, using the API-based approach to accessing infrastructure that speeds up your development. Player lifetime value, this relates mostly to things like analytics and machine learning services that we provide to enable you to sort of understand your player behavior better. And last but not least, at AWS, we are heavily focusing on the games industry. And this means that we have game tech specific services. So for example, we have a service called GameLift, which is specifically designed to host session-based games in the cloud. All right, yeah, I'm going to cover the sort of how AWS global infrastructure is laid out and how this relates to the different needs that I mentioned before. And let's actually start with the regions. So as you can see on the map, this is definitely something that we have a lot of focus on. So having a global reach, being close to your users, in your case, it's players, of course. In the first 5 years, we had 4 regions, then extended in the next 5 years to 7 additional regions. Between 2016 and 21, we added 14 more regions and 5 local zones. So local zones are something that is sort of an extension to a region, but it's in a different location. So again, being able to, for example, host your game servers close to your players. And we have plans for released plans for 5 new regions and 12 more local zones. So of course, obviously the idea is that you have the infrastructure exactly where you need it available. All right, briefly on the region design. So this is maybe the most technical slide in my deck. So AWS regions are comprised of something called availability zones. So an availability zone is a cluster of data centers, and a single AZ or availability zone is physically isolated from the other ones. So it means that if there would be any issue or natural disaster or anything in one of the availability zones, it doesn't affect the other ones. And it means that when you build your solutions or your game backend services in a way that they make use of multiple availability zones, you increase your availability through that and sort of can make your backend more reliable. Also worth mentioning that the regions are sort of isolated from each other, so you always sort of know if you have requirement. For example, GDPR requires you to have the data of your players in EMEA, in EU. In Europe, you can actually deploy those resources in, for example, the Ireland region or the Frankfurt region of AWS, and be sure that the data stays within that region. Another service that I wanted to cover, or another sort of piece of infrastructure, which is a pretty significant one, is our points of presence around the world. So we have, in addition to the regions, we have something called edge locations, and we have 230 of those around the world. And these are used by only a subset of the services, a key one being Amazon CloudFront. And this is what you would use for your content delivery and some other use cases as well. So for example, if I as a developer would deliver my game updates through CloudFront, maybe backed up with our managed object storage S3, I as a user then, or a player, would access that content directly. I'm based in Helsinki, so I would be accessing it from the Helsinki edge location, meaning that it can be cached on the edge. All of this is automated for you, and it means that your users will get those downloads significantly faster than always going to the source. All right. So some sort of best practices on deploying your game globally. So first of all, something you need to choose is your deployment strategy. And as a sort of, if you're an infrastructure architect or your backend developer, you want to design this early on. And of course, it comes from your business requirements. Where do we need to be? What are our latency requirements? And you need to architect based on that. So it might be sufficient that you're in a single region. For a certain game type. For another game type, you need to be absolutely everywhere. So for example, Epic Games runs Fortnite on AWS, and obviously they make use of our global infrastructure very heavily to provide the low latency experience. So an example, a common one that I see is that you have a single region for your backend services. So this can be in any of the continents, maybe where your majority of your players are. And then you deploy your game service globally if you're hosting a session-based game, so making use of multiple regions. And then you use the content delivery network for any sort of content that the game client needs to download. Another best practice is to use infrastructure as code. So we have something called AWS CloudFormation, which is a way to define your cloud infrastructure or game backends as CloudFormation templates. And it means that you can deploy the same stack of resources using these templates across multiple regions. And this simplifies the deployment of your resources and also the updates to your infrastructure. And then last but not least, leverage managed services. So I briefly mentioned Amazon Game Lift in the first slide. So this is a managed service for hosting session-based games. And essentially what it means is that you upload your game server build, you define like in which regions these fleets are deployed into. It has a built-in matchmaking component, and it can also provision game sessions to players based on their latency. So grouping players close to a certain region and making sure they are hosted in that specific region. So GameList simplifies the sort of session-based games backend management significantly, or game server management. Amazon CloudFront, as I already mentioned, is your content delivery network service. Essentially, you deploy a single CloudFront distribution, you define where the source data is, and then your game client just has a single DNS endpoint and will access the data from the cache in the edge locations. Another one that I wanted to add is AWS Global Accelerator. So this is a networking service that sends your players' traffic through AWS Global Network Infrastructure, and this improves your performance significantly. So, for example, if you have your game backend, your central game backend services hosted in a single region, you could make use of Global Accelerator to sort of accelerate the connection from the client to the game backend. And this again uses the edge locations and the sort of the global private network of AWS. So if I would access the backend from Helsinki, I would go through the Helsinki edge location, and my request would go through that all the way to the backend service. All right, I think I'm done a few minutes early, which is probably not an issue for the schedule. So thank you for your time. Yeah, my email is there, so if you want to reach out, I'm happy to get you in contact with our sort of local account teams in UK or wherever you are. Yeah, hope to see you building backends on AWS.